All right, hello everyone, and today we're going to cover how to do a compound interest problem. So let's get started here. Okay, so first thing, let's take a look at our formula. Okay, so this is the formula you're going to need to know. So A, which is the final amount in the account, that's important. Our P is our starting principal, or our starting amount. The R, again, just like in the previous one, is our rate, typically given in years. N is the number of times it compounds. We're going to talk about that on the next slide. And again, notice how it appears twice. And then T is our time, typically again in years, and R is our interest rate, our yearly interest rate. All right, so let's get a look at some of this other interesting stuff here. Okay, so first thing we need to do is fill out this stuff, our compounding. This is going to be our N values. Okay. So we're going to need to know how these work. So again, if something's compounded quarterly, so again, if you think of a football game, there's 4 quarters, or a quarter, in terms of money, there are 4 quarters makes $1. So again, this is easy, that's 4. Semi-annually is twice. Compounded daily is 365. Unless they throw you a trick and tell you it's a leap year, then it's 366. Weekly, there's 52 weeks in a year. Monthly, that's 12. Annually, well, that's only one time, so 1. Compounded every 4 months, since there's 12 months in the year, it does it once every 4 months. So that's going to be 3, because 12 divided by 4 is 3. And bi-weekly is going to be 26. So you are going to need to know these numbers all through here to be able to do this. Otherwise, you're going to be in big trouble because you're not going to know how to put the right numbers in. Okay, so let's take a look at our first example. Okay, so I'm going to shrink this a little bit, move it up here. Okay, so here we go. We're going to start by reading the problem first. We're not going to do anything else but read it. It says, how much will $4,000 amount to after 5 years if it's invested at 8% interest compounded quarterly? All right, so starting with our formula, let's start with that. I forgot to put that on the slide. So A equals P times 1 plus R divided by N raised to the n-th power. Okay, so let's fill in again. Let's highlight what we know. Okay, so $4,000, that's going to be our starting principal. After 5 years, that's going to be our time. Okay, invested at 8%, that's my interest, but remember it goes in as a decimal, so it's going to go in as 0.08, and we'll do our little markup on the side. And the last important thing is compounded quarterly. So that's going to be our N's here. Okay. So now what I usually do is I fill in our variables. So A, P, R, N, T. Okay. So the ending amount, I don't know what that is. Our P, our starting principal, starting amount is 4,000. Our rate is 8%, so it goes in as 0.08. Compounded quarterly means it's going to happen 4 times in a year. And the time is going to be 5 years. Okay, so we have everything we need. So let's fill this in. A equals 4,000. 1 plus, I'm going to have 0.08, my rate, divided by 4, raised to the 4 times 5 power. Just filling in everything that we know. Okay, so now at this point, we're going to start working on the math. We always start in the parenthesis, and I'm going to start right here with this division. So A equals 4,000. 1 plus, now 0.08 divided by 4 is 0.02. And I'm going to times it at the same time because I can. That's pretty easy. It's going to be 20. Okay. So now A equals 4,000. I'm going to put this together. I'm going to get 1.02 raised to the 20th power. Okay, now according to order of operations, I'm going to do this part next, raise that to the 20th. So A is equal to, and again, the 2-year-old Gwen is sleeping, so I can actually use my calculator, which is really nice. So 1.02 raised to the 20th power, I'm going to get 1.485947396. Okay, now I'm going to shrink this a little bit, move it up. Okay. And now we're going to times these pieces together. So times that previous answer by 4,000 tells me I'm going to have 5943.789584. But again, realize, think about what we're dealing with here. We're dealing with money. So I'm going to round to 2 places. So this is going to be $5,943.79. So that's how much is in the account after 5 years. Okay? Oh, so there's that one. All right, let's go to the next problem. All right, so I'm going to shrink this a little bit. Now again, first thing we're going to do, let's read our problem. We don't do anything else but read it. Okay, so how much must be invested at 10% compounded semi-annually to yield $10,000 after 6 years? All right, so let me start with the formula. I wrote with my highlighter on. A equals P 1 plus R over N raised to the n-th power. All right, now let's go through this again. Okay, so how much must be invested? 10%, so that's my rate. Compounded semi-annually, so my number of times is going to be n. To yield $10,000, that's what they want in the account after everything's done, after 6 years. So that's going to go there. So we're looking for the principal. So A, P, R, N, T. Okay, so let's fill in what we know. So A is going to be $10,000. P I don't know. My rate is going to be 10% or 0.10. Number of times semi-annually is twice. And the time is going to be 6 years. All right, so let's fill it in. Okay, so we're going to have 10,000, I'm sorry, equals P 1 plus 0.10 over 2 raised to the 2 times 6th power. All right, so now we're going to do the math inside the parentheses. So 10,000 equals P 1 plus, now 0.10 divided by 2 is 0.05 raised to the 12th. So 10,000 equaling P 1.05, come on, 5 raised to the 12th. Okay, now I still can do this math right here, so I'm going to do that. So 10,000 equals P times, so on my calculator, 1.05 raised to the 12th power is 1.79585626. Now I'm going to keep this in my calculator because my next step, because I'm trying to solve for P, is I got to divide this 1.79 blah, 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 blah. Okay, and I'm not going to round. Do not round this right now. We got to keep this whole thing in the calculator. Because if you keep it in the calculator, you're just hitting the previous answer button. So we're going to do 10,000. Type 10,000 on your calculator, divided by, and you do your previous answer. So again, that'd be like second function, and then you do looking for an ANS button. Okay, that'll give you the previous answer. And then hit equals. And when I do that, I get 5568.341. Correction, hold on, I was wrong. Get rid of that part. It's 374182. And again, remember, since we're dealing with money, it's going to be 5,568 point. And again, the 4 says the 7 says, so it's going to be 37 point, not a comma. So that's what you have to invest to start in order to make $10,000 after 6 years, or have $10,000 after 6 years. All right, let's keep moving. All right, so next one. So again, we're going to read the problem first, and I'm going to put the formula up. A equaling P1 plus R over N raised to the n-teeth. Okay, so let's read the problem. So it says $500 grew to $1,230 in 3 years. What was the rate? It was compounded weekly. Find the interest rate. All right, so let's start. 500 bucks. That is my starting principal. Grew to $1,230. That's how much is in the account afterwards. In 3 years' time. Time is 3. Okay. When the rate is compounded weekly, so that's the number of times, and we're looking for the rate. Okay, so A, P, R, N, T. So ending amount 1230. Starting amount 500 bucks. The rate, I don't know what that is. Compounded weekly, that means is going to be 52 times, and the time is going to be a 3-year time frame. All right, so let's fill in what we know. 1230 equals 500. 1 plus R divided by 52 raised to the 52 times 3. Like so. All right, now here's where the fun begins, because I really can't do any work in here. So our start is going to be dealing with this guy. We're going to divide it off. And yeah, we can times this together too if we wanted to. I'm going to reduce by at least a factor of 10, so I get 123 over 50 equals to 1 plus R over 52 is raised to the, this is going to be the 156th power. Now at this point, in order to get in here to get at the R, I got to get rid of this. So I'm going to raise this to its reciprocal of 1 over 156. I know you can't see the 1 here. Okay, we're going to raise both sides. So technically what you're doing is taking the 156th root of this, but it's easier to do it this way. So on my calculator, when I type this out, I'm going to open a parenthesis. I'm going to type 123 divided by 50. Divide by 50. I'm going to close the parenthesis. Raised to the, and then I'm going to open another parenthesis, do 1 divided by, oops, 1 divided by 156, and close the parenthesis. So when I do that, we're going to get this ugly decimal of 1.005786945 is equal to, now these canceled, leaving 1 plus r over 52. I'll give you guys a second. I'm going to shrink this and move it. Now we're not going to round anything yet, because now I'm trying to solve this. So I'm going to minus the 1. So I get 0.005786945 equaling to r over 52. And now to finish, I'm going to times both sides by 52 to clear out the ugly fraction. And when I do that, I get 0.300921145 is equal to r. 57, not 54. Come on. 57 is equal to r. Now remember, I'm going to shrink this while you guys are catching up. Now at this point, we are told to give this as a percentage. So again, we have to take this answer and times it by 100. So you're going to get 30.0921147% is equal to r. And now I'm going to round to 2 places. So it's 30.09% is equal to r. All right. So there's that ugly one. All right, let's move on to the next one. All right, so this one, because we're probably going to be looking for time, we're going to be using logarithms, just to give you the heads up. So let me write our formula. A equaling P times 1 plus R over N raised to the n-teeth. All right, so let's read our problem. How long does it take for $1,000 to grow to $2,500 if it's invested at 5.5% compounded monthly? All right, so let's go through this. How long does it take $1,000? That's our principal. To grow to $2,500, that's our amount afterwards. If it's invested at 5.5% and it's compounded monthly, so that's these guys. Okay, so A, P, R, N, T. So my A value is 2,500. Fix that. Our principal is 1,000. Our rate 5.5. So as our decimal is 0.055. Compounded monthly is 12. In time, I don't know. All right. So let's fill in what we know. Okay, so 2,500 equals 1,000. 1 plus my rate of 0.055 divided by 12 raised to the 12th power. Okay, now I'm going to start in the parenthesis because I can. So 0.055 divide by 12. So I get 2,500 equaling 1,000 times 1 plus, I'm going to have 0.004583333 raised to the 12th. And again, do not clear this decimal out. Keep everything in the calculator because it'll help you. Because now my next step is we're going to add the 1 to that decimal. So 2,500 equals 1,000. 1.004583333 raised to the 12th. Okay, now here's where the fun begins, because I got to get this exponent down now, but I can't do that with this still kicking around. So I'm going to divide by the 1,000 to get rid of it. Now, I am going to reduce a little bit here. I can do doubles the zeros by multiples of 10. And 25 over 10, I can reduce to 5 halves. If you want to keep it 25 over 10, or keep it 2,500 over 1,000, you're more than welcome to do so, but it's not really all that needed. Equals 1.004583333 raised to the 12th. I'm going to shrink this a little bit while you guys catch up. Now at this point, now I'm going to take the log because I got to drag this exponent down into the main problem. So we're going to do the log 5 halves equals 12t times log 1.004583333. Oh, hey, there we go. All right, now we got to get the 12t alone, so we're going to divide by this monstrous log. 0, blah, 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 blah. Log 1.0045, blah, 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 blah. Okay, now I'm going to shrink this again. Now again, very important, we're keeping this all in the calculator. Now you might want to store this because we're going to need it after, because we're going to do another function first. If not, just have this number here written down because you're going to have to punch it back in. Okay, so here we go. So let's do log 5 divided by 2 equals, I get 0.39794000087 divided by the log of the 1.004 blah 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 is equal to 12t. Now here's where having a graphing calculator is very helpful because you can arrow up to this answer up here when we do this. So we're going to take this answer, the 0.39, I'm going to divide it by log of the 1.045 and some change, and hit equals. I forgot to shrink this some more. So when I do that, I'm going to get 200.3757886 is equal to 12t. Now obviously we're not done yet because we still have this 12 here we got to get rid of. So we got to divide by 12s. So when I do that, oops, scooch this over here, I'll move this up here. How about that? Pretty neat, huh? So I'm going to divide that by 12. Divide by 12 to finish. I get 16.69798238 is equal to t. So I'm going to round to 2 places. That's going to go up. So this will be 16.70 years is equal to t. A lot of fun on that one, huh? Alright, so that's the end of this tutorial video. Hopefully you learned a lot, and I will see you in the next video.